Hi all, welcome to Riot's Lunch and Learn series, the place where we spotlight Riot sponsors and partners. My name is Jen Morgan and I'm the Virginia program lead for Riot. Just a couple of quick reminders before we get started. This event is being recorded and will be posted to Riot's YouTube channel and uploaded to the meetup page where you registered for this event. If you have any questions throughout the presentation, please place them in the chat. We ask that you please place your questions in the chat and so that they can be read aloud and for those watching the presentation at a later time. We will be monitoring the chat throughout the presentation and the questions will be read aloud as they are placed. Finally, please keep yourself muted throughout this presentation to try to help mitigate any background noise. Today, we have Paul Peterson from Arrow to discuss IP everywhere, how Matter, Sidewalk, and emerging protocols are revolutionizing IoT. Paul, I'll turn it over to you.
Okay, thank you very much, Jennifer, and I am appreciative of the people that are joining today, and hopefully you'll find something that's beneficial as we go through the talk today. Should have about 45 minutes of material here to talk through, and as Jennifer mentioned, if you have questions, please kind of put them in the chat and we'll get to them as we kind of go through and look through this. First, as a form of introduction, I'm a field applications engineer with Arrow Electronics. I've been with Arrow for about 30 years, and we've been a sponsor of Riot since about 2015. Hopefully you guys may be aware of Arrow, but if not, I'll give you kind of a quick overview of who we are and what we do and things of that sort. Arrow, at the end of the day, as I like to say, Arrow is the world's largest distributor of electronic components. We service about 200,000 customers worldwide. We have about 22,000 employees, many of which are engineers. We have just under 4,000 engineers at this point. Fairly large company, as I like to say. It's a company a lot of people may not have heard of, but we touch many aspects of the technology industry as a whole. As a distributor, we don't really make many of the products ourselves, but we are a distributor for most of the main semiconductor as well as the interconnect, passive, and electromechanical suppliers that are produced worldwide. We can cover essentially 90 to 100% of all electronic component usage on a typical printed circuit board. Now, with that, we kind of get the distinct advantage of kind of being on the leading edge of technology, because technology is really enabled by the building blocks that are made available. And those building blocks are, done through the innovation of many of the suppliers that you see listed here. And these are the suppliers that help us enable kind of the next generation technology and things of that sort. So we'll leave it at that. I don't want this to be a marketing presentation about Arrow. I want this to really talk about what where are we when it comes to the Internet of Things. Our agenda today, we're going to talk a little bit about a brief overview of some of the existing protocols that are out there, and what today's problem, as kind of we see it, and define what is kind of the consumer dilemma of IoT, in particular wireless protocols. We're going to talk about, do a brief kind of comparison, if you will, the pros and cons of various protocols out there. But primarily, we want to talk about kind of some of these emerging technologies that we think is going to bring a lot more unifying technology, a lot more co-compatibility, if you will, among these different protocols out there today. For example, Matter, Amazon Sidewalk, Wi-Sun. These are all technologies that we've kind of begun hearing about in the past, say, 2 years or so. And it's kind of, I like to say that IoT has kind of gone from our formative years, maybe even through our adolescent years, and we're kind of getting to that point where we're kind of reaching a mature phase where all of these different technologies we're having to stitch together so they work seamlessly. And then we'll kind of wrap up with a quick summary. Okay, so I've done presentations, various presentations within, the Riot group over the years. And it's interesting because, when we think about this, and I've talked, with the Riot, founders and things like that, what do we really mean when we say the Internet of Things? How do we define it? Well, like many people ought to say, oh, let's go out, see what Google has to say about it, or Wikipedia. And this is probably one of the best, descriptions I've seen out there. The Internet of Things, is that network of physical objects or things embedded with electronics, or what Arrow happens to sell, that has software, they sense their environment or do whatever, and then provide that through some form of network connectivity, which enable these objects to collect and exchange data. A very nice definition. But what's interesting to me about it is, as we look at the definition of the Internet of Things, what's interesting is that wireless is really only implied in that definition. And that's what's kind of interesting as we think about, the Internet of Things, because we think about, connected cities, we think about Bluetooth widgets, we think about Wi-Fi products, and by definition, all of those things are talking about some form of wireless connectivity. And that really is not a single type of wireless connectivity. It's really, many dozens, if you will, of different technologies. I love this picture. I like to go back. I'm kind of as I get older and, have been in this industry for a long time, I like to look back at kind of what were the building blocks that we built upon. And this happens to be one of the first time I remember seeing a small, what I would say, embedded product that could attach to Ethernet and therefore connect to the internet. And, going back to around 1996, kind of interesting, 27 years ago or so, we really did, we think about IoT as being a relatively new phenomenon, maybe the past 10 years, but it really is, we're approaching 30 years that we have actually been able to take an embedded product and connect it to the internet. Now, obviously, this product did not have wireless connectivity. In fact, in 1996, Wi-Fi was still just kind of in a conceptual stage. We don't really see, for example, Wi-Fi connectivity, which was arguably maybe the first wireless on-ramp to the internet, until, the early 2000s, maybe 2003, 2004, a good 8 years later before it becomes mainstream. So it's kind of interesting that the Internet of Things is not that new, but some of the wireless technology is. And there's a lot of them. I'm not going to go through every detail of this, but we didn't mention, for example, hopefully you can see the laser pointer, where Wi-Fi fits. Wi-Fi clearly is, part of the wireless infrastructure, if you will, of the Internet of Things. But we see the emergence of a lot of other things. Bluetooth low energy, Zigbee. We see these other protocols, for example, cellular, LTE, Cat-M, targeting the Internet of Things. This NB-IoT, which again is a cellular, or sometimes what we call a fixed wireless kind of infrastructure. LoRaWAN, Sigfox, which actually Sigfox is only been adopted in Europe and not necessarily mainstream these days. Also, we see things like near field communications, or NFC, things like the ability to, tap to pay kind of things, reading, for example, NFC tags. All of those are kind of different wireless technologies that were designed to solve different problems, but they've kind of come together. The Internet of Things, if you will, has kind of taken pieces from all of these different pieces, and we've tried to work on, make those work together. So let's take a look at this. Is highlighting some of the low power wireless technology, and we don't necessarily consider Wi-Fi as low power, although that is changing a little bit. But things like the 2.4 gigahertz proprietary network has actually been around for some time. Anybody who's played around with a wireless mouse or keyboard or what have you, has basically has been using some form of like a 2.4 gigahertz wireless technology, and that's been around for some time. So things like toys, gaming, remote controls. Bluetooth, I don't want to minimize the impact that these things, smartphones, tablets. I mean, I've got several right here in my desk. How that, those have revolutionized the way that we think about the Internet of Things. Many products are now based off of Bluetooth and Bluetooth Low Energy. For example, medical type devices, wearables for fitness trackers, things of that sort have used Bluetooth. And what's interesting is that our smart device in those instances becomes our gateway. They are our on-ramp because they happen to speak Bluetooth, but they also have Wi-Fi or cellular connectivity to go to the internet. And then also beyond that, as we go through, there was a standard. It's been around actually for quite some time. This IEEE 802.15.4 standard. IEEE is basically the standards organization for the electronics industry, so to speak. And we see that there have been various protocols that have been based around this wireless packet structure called 802.15.4. And things, for example, like Zigbee and Thread have been built upon that. And Zigbee has been around for a long time. In fact, many people may not realize that, for example, most electricity meters that have been sold in the past 10 to 15 years likely has Zigbee radios built inside of them. But they haven't become mainstream, at least not yet. And we're talking a little bit about that. And then, we'll continue on, and beyond that, we'll talk about Thread, which basically added an IP layer, the Internet Protocol layer, upon this 802.15.4. We'll talk about that. Bluetooth Mesh, the Bluetooth Special Interest Group created, a network that basically allowed multiple devices. And we actually see Bluetooth Mesh in things like lighting control. Some smart home type applications are using Bluetooth or Bluetooth Mesh. And then ultimately we kind of get into that wider area or wide area network where we see standards like, again, cellular, LTE, 5G today, as well as some other standards that are not cellular based, like LoRa, LoRaWAN, and things of that sort. So a little history of kind of where we got here. But here's the dilemma. What's interesting about it is if you've gone to a home improvement store lately, you're likely going to see a display like this. I love this picture because I think it summarizes what's happened. And that is that all of these different various standards, each with their own kind of set of rules and on how they communicate, have come out, and we've been trying to take these different standards and bring them to market. But what we've done is created a whole bunch of confusion in the whole infrastructure. Multiple ecosystems are available out there. You can see here we have Zigbee and Z-Wave and Bluetooth and Wi-Fi. And in some cases, I love this right here, we've got two products that basically do the identical function, but they're on different networks. So devices, unfortunately, a lot of times if we choose, okay, I have a Zigbee network for my home network, then that means that I can't use this Wi-Fi, over here that will interact with it. Manufacturers, people who are doing the innovative things around the Internet of Things, are forced to pick an ecosystem today that basically says we are going to, promote Bluetooth, or we're going to do a Wi-Fi based system, or whatever. And they basically have to start from the beginning of their development to say, okay, this is the network that we're going into. And you basically have to understand not only the different IoT technologies, but you have to also understand the all the certification requirements. If I'm going to go for Bluetooth certification or Wi-Fi certification, all these different standards require cost to certify. They require, emissions testing, FCC testing, things of that sort. So what's happened is in the retail environment, it's created a big problem. And that is, how do I know which products I have on the shelf? It's difficult for consumers, even I would say technology savvy consumers, to really know what is compatible with each other. And the biggest problem, one of the things, and I come back to this, is this high return rate. That's the death knell. We've actually unfortunately seen customers who hadn't quite thought through the whole, what happens if the product doesn't work. I heard one customer say, we're given 3 opportunities to get a product on, for example, a Wi-Fi network. After the 3rd opportunity, if I'm not successful in connecting, typically the result is I box the product back up, I drive it back to the retail store and return it. And those returns create all sorts of, bigger problems for the maker of the product and the retailer and things like that. Creates a lot of purchasing confusion. It's hard to mix and match products they want, and it's difficult to change ecosystems. So when I say we're kind of at that past that adolescent stage, maybe moving into this, I think this represents where we are. Everybody was kind of looking at different protocols and things like that. I'm going to breeze through this next section because I really do, I want to talk about the pros and cons of various protocols. Again, this is more of how we got to where we are today. So let's look at this. So, Wi-Fi. What is great about Wi-Fi? Well, as I like to say, the best thing about Wi-Fi is that by definition speaks IP, or the internet protocol. It was designed as a form of getting us, Ethernet, if you will, wirelessly, and Ethernet being the backbone. It's kind of interesting, but Ethernet is the backbone of what our modern day internet is built around. So it's basically, it's been around for a long time, like I said, since the early 2000s. And it provides a whole suite of different protocols. You may be familiar with things like HTTP, HTTPS, MQTT, all these different protocols that the IP allows. It's been dominant. It is a complex stack, if you will, of software. And Wi-Fi itself is a rather complex, requires complex radios, more so than, say, Bluetooth or things like that. It's great for customers who want to, get their IoT devices connected to existing infrastructure, because it's there. It also is one of the problems is it has to typically access some form of an access point. And if that access point changes, then we can orphan. And if we have, say, and many people experience this today, I changed my access point, my Wi-Fi router, and now I've orphaned devices. I may not even know that was transmitting data via Wi-Fi. I have to go in and reconfigure and things of that sort. Another downside where Wi-Fi doesn't fit is Wi-Fi traditionally, up until recently, I would say, and even then, is not conducive to running on these things like coin cells, small batteries that, we physically cannot run Wi-Fi, not easily, on a coin cell. So we're relegated to either something that's plugged into the wall, or has a larger rechargeable battery pack, or replaceable batteries. What is interesting, though, is that 86%, one of the reasons it's so popular, of homes have some form of internet, primarily through Wi-Fi. Bluetooth low energy. Bluetooth low energy has been around. It was enabled primarily by the cell phone guys to connect, smaller devices, widgets. We've seen, like I said, fitness trackers, medical devices. There's dozens, appliances even, things like I can control my blender with my smartphone. Not certain why you want to do that, but things like that are there. Very good. It is good for a short range, typically about 30 meters max. In some cases, there are variations that allows us to have longer range, but typically, around 30 meters. Good for, maybe to the adjacent room in a home or things like that. And it does this, kind of by definition form a point-to-point network. And it's also very good. We can run Bluetooth devices on this little, coin cell, because it uses very little power. That was the definition of LE, or low energy. The downside is it doesn't really, speak, Bluetooth itself doesn't really speak IP. It needs some form of a device like a smartphone or things like that. If I want to spray that data into the cloud, then I'm going to have to, have something that can talk Bluetooth and send it up, to the cloud. Bluetooth mesh is a variation. Basically, the ability to have Bluetooth devices communicate with other Bluetooth devices. It was added as part of the Bluetooth spec that allows us to have, create Bluetooth mesh networks. And it kind of entered a crowded field, I would say, where like Z-Wave or Zigbee had been. But we do see, Bluetooth mesh used for things like commercial lighting and things of that sort. It's not a Bluetooth mesh. Typically, some of the power advantages go away because to do a mesh, I have to have other nodes that are powered that are continually listening for other devices. Zigbee. Zigbee is an interesting protocol because, like I said, it's been around for some time. And there's a large number of industries that have kind of aggregated around it. Like I said, a lot of the utility companies mandated, for example, electricity meters were, to put Zigbee in the e-meters, thinking that at some point I could do time of use control, things like water heaters or thermostats or things like that. And that, while some of that did materialize, it never hit critical mass or mainstream. So it is a large industry alliance. It's based around 802.15.4. Zigbee does add a mesh layer. It can add a mesh layer that allows multiple devices to communicate to other adjacent Zigbee devices and kind of create this mesh from point to point to point until it reaches some form of a gateway. So, Zigbee is actually today, as we're seeing certain things like Amazon hubs that enable Zigbee, we're starting to see kind of that, the emergence of, newer Zigbee based parts and things like that. And, Zigbee again is kind of creating an infrastructure back to, point to point. Zigbee by definition itself did not speak IP or internet protocol. Now there have been provisions added to it on something called like Zigbee IP, but Zigbee by itself was, thought that it would be communicating to a Zigbee specific gateway that would then get onto the internet. So simple hubless applications, sensor to smartphone is not really what Zigbee is targeting. Okay. Z-Wave, this interesting. Z-Wave was actually kind of established as a alternative to Zigbee. And one of the problems that was interesting is it was built on sub-gigahertz technology. What I mean by that is many of our IoT devices either use 2.4 gigahertz, which we've seen on other devices like Wi-Fi, for example, uses 2.4 gigahertz. It's an open, what we call ISM band. But Z-Wave was built upon sub-gigahertz, or in the US, it's 900 or 915 megahertz as an open ISM band that allows us to communicate. If you think about all of the devices in our home, our smartphones, which are with Bluetooth is 2.4, Wi-Fi, which is everywhere, consumes a lot of 2.4 bandwidth. 2.4 is a very crowded environment. And it's interesting that Z-Wave was touted as a way to go to sub-gigahertz. But it is now an industry, it was a private kind of entity, but now has been established as an industry driven standard. But it also made some of the provisioning easier than, say, with Zigbee and Wi-Fi. It is backward compatible and it's still alive today. But it hasn't been adopted by some of the other infrastructure guys like Amazon, Google, and Apple really never embraced Z-Wave. And these entities really are calling the shots in a lot of ways about how protocols interact as we get to the internet and and the Internet of Things. If you're looking for just a simple sub-gigahertz network, Z-Wave is overkill for that. But there are things out there where we see long range sub-gigahertz where you don't need the full Z-Wave stack, so to speak. All right, Thread. Thread is interesting. It much like Zigbee is based on 802.15.4, but it adds this IPv6 or Internet Protocol with IP addressing. And Thread has been around, actually Thread's been around for a while as well, but it's basically been, established as kind of an open source, environment where people can use and innovate around it. It by itself does not define an application layer, but Thread is, because it does speak IP, is not a bad way to get devices to talk, to the internet, an Internet of Things based on Thread. Problem is that without other existing infrastructure, Thread still requires some way, like Wi-Fi requires an access point, Thread would require some form of router to get information to the cloud. Where does it fit? Customers looking for a Zigbee alternative with their, who's written their own application layer. Customers who make in-devices targeting Google's ecosystem. And this is where it gets interesting, because we're beginning to kind of see how the industry is beginning to come together over various protocols and offer the ability to, make the Internet of Things a little more accessible and usable. When does it not fit? Customers who don't want to make their own border router, unless they're planning on using a third party like a Google Nest Hub, we'll talk more about that. Or customers who want just a traditional, like for example, Thread environment. And there are entities like this, people who do specific, let's say, Thread in lighting or things of that sort, who wants to do a very specific lighting control. They can still use Thread. It's certainly open to do that, but they may want to build their own access point or gateway in doing so. HomeKit. Okay, what is HomeKit? It's Apple's smart home ecosystem, and it's, Apple was basically early on and said we need to develop, kind of an environment that allowed us to, to control our fellow Apple devices out there. Apple, as we know, was kind of, they like to kind of support their own infrastructures and things like that. Uses native home apps in iOS. It was all built around, interfacing to iPhones, Apple devices. Previously, HomeKit was modeled around BLE and Wi-Fi only, but now it's essentially, and this slide actually has a little bit of time on it, that basically they're moving all in on Thread. And what's interesting is HomeKit made itself upgradable to this open standard called the Connected Home over IP or CHIP standard, which ultimately has been rebranded now as Matter. So it's interesting that we see with Matter some of these common, interface, open standards, if you will, BLE, Wi-Fi, and Thread that Apple was working towards, now coming up with this thing called Matter. Previously, HomeKit, requires Apple certification. It has to go through the Apple, certification process, and it's been around. Actually, it's been around for a few years. Where does it fit? Smart home and end devices who want to integrate with Apple's ecosystem, but it doesn't fit on things that are using closed or proprietary protocols. Somebody who says, I want to do Z-Wave, HomeKit is not there. So we've mentioned Matter now a couple of times, and this is what's interesting about it. So what is Matter? It's an alliance, and I read an article one time that said, if you'd ever said that Google, Apple, and Amazon would ever come together and agree on a one standard, you're kidding yourself. But the reality is that's exactly what has happened under Matter. It is an alliance of Google, Apple, Amazon, and others that are attempting to solve that dilemma we saw earlier, because that's got to be the key problem that is solved. We cannot keep confusing, not only consumers, but also developers, and that, are having to make a decision. Do I make 6, 7 different, wireless type products because of all of these different standards? So Matter is basically the industry realizing we've got to come together. And it's built upon existing multiple protocols that have been around, Wi-Fi, Thread, BLE, and actually others that are there that are coming together. And this is recent. Matter really has only been, ratified as, since really, in the past, say, 8 months or so, where, the preliminary spec was ratified. So this is kind of the new things. I got a little bit more. So, I called it what is, I was going to say what is the matter, but what is matter? And it's basically the industry coming together, not only the, main providers like Amazon and Apple, and things like that, but also the silicon providers where Arrow plays, Scilabs, Nordic Semiconductor, Infineon, Texas Instruments are all making products in there. Samsung and their smart things has embraced it. So we're seeing basically matter as this, industry standard that's being, driven and pulled together. And basically, at this point, even though it's relatively new, over 280 industry-leading companies have signed up already. It makes setup, and control your smart devices within multiple ecosystems. It's interoperable, and that's the key behind Matter. They are, those devices, and you'll notice that there's a logo, much like how BLE has a logo. If you see these little, this right here means it's basically Matter compliant. They're interoperable by design. They're reliable. They all, how they're provisioned and everything else like that works the same. Secure. That's one of the big pieces that not all of these older protocols, provide security by definition. How this data is encrypted, certificates are shared, encryption keys are stored is all part of the secure layer. And Matter, to be part of a Matter in ecosystem, you have to, show that you have minimum levels of security within the products. It is open, and what I mean by that, it is IP based. It is a universal standard for the smart home. It will run on Wi-Fi, Thread, and existing Ethernet. Remember Ethernet, the wired version of it. We can still have IoT things that are wired in. So simplifying it, basically, developers can now begin to develop in kind of a, instead of having to target multiple different devices, they can say, well, if I target Matter, I can hit, multiple of these networks. It solved some of this retailer dilemma, with consumer products. And it is simpler by doing Matter. You can enable, identify that you work with multiple different ecosystems, simplifies that purchasing experience, and ultimately provides a better experience on trying to provision and things of that sort. So in the past, let's say since the beginning of the year, so within 5 months, we're seeing products roll out that have support. Now, again, I said, keep in mind that I said that Matter can be layered upon Thread or Wi-Fi now, and Ethernet for that matter. But as we're seeing, for example, like the Amazon Echo Gen 4, the Eero 5, these are all products that that are there. There'll be mobile app support pretty much now. It's kind of, it's online. Apple with their iPod, HomePod Mini, Apple TV, and HomePod have support for Matter. Nest, Google Nest, the Nest Wi-Fi with being Google and Android support, coming this year, iOS support in 2023, Android today. And then Smart Things, which is again the Samsung, branded TVs, charging hubs, refrigerators, all of these are going to have support for Matter or Thread. And not only as that, but also the ability to make that network available, for other devices as kind of a bridge or a gateway. Over Wi-Fi, a lot of the other products, your connected speakers, I won't go through all of them, but you can see this list is growing fairly rapidly. So Matter, in essence, like we said, Wi-Fi, Thread, BLE, does base itself on what we call IPv6 or the Internet Protocol version 6, which has been around. Again, keeping in mind that Thread was the IPv6 implementation of that over 802.15.4. So as we take a look at IPv6 and we take a look at the protocols that are there, these are the actual physical layers that that we have. Again, Wi-Fi and Thread are going to be the primary ones. I don't know if you can see that, but it says BLE for commissioning only. When I bring a product home and I want to get it to work with my other existing devices, the idea being I will be able to use my smart device, scan a barcode or a QR code of that device, provision that device using a simple Bluetooth link, and then have it connect to the Matter network very, very simply. And that's the idea behind, ease of provisioning, and the ability to work on networks. Okay, so as we take a look, we'll see, for example, Wi-Fi and Thread is the basis of that. The idea that Thread devices will require border routers, but those border routers are going to be existing products that we may already find in the home. Your Echo, your other, smart speakers become a gateway, if you will, or your, border router between my Thread or other devices into my existing Wi-Fi infrastructure and ultimately to the cloud. BLE will be, as I said, we use for commissioning, and then we'll have the other protocols that emerge can be layered around Matter. So it's interesting that by this we see, for example, different definitions. There'll be line-powered devices, things that may not require ultimately very, relatively low power. For example, like lighting, electrical, things of that sort. Media devices, even powered speakers or things like that. So we'll see different categories or classes of Matter devices. And as Matter expands, we're going to see more and more devices being added. There's battery powered, HVAC controls, door locks, window coverings, sensors. All those things are protocols or definitions, if you will, under Matter. Matter network components, a platform, a mesh extender, border router. We talked about how your Echo becomes a border router, and that network is enabled today. And then a device commissioner, which is something that can bring devices into and out of the network. A controller is something that controls the flow of data, and then ultimately the bridge that gets us up into our gateway. So other devices like cameras, home appliances, your robot vacuums, EV charging, all of these are other protocols that are being defined that will be supported under Matter. So with that, that kind of is the next level of this new and emerging protocol called Matter. In the next few minutes, I want to talk about two other protocols. And while they may appear like they're trying to solve the same or similar function, is actually different. And I know it can be a little confusing, but I want to kind of go through these because this is also kind of interesting. I've always thought, wouldn't it be neat if within Wi-Fi access points, we had kind of a sub-channel that we didn't have to provision, we didn't have to type a password in. I could take my little widget of whatever, my sensor, my water level sensor for my basement or whatever, and just have it connect to any available access point when needed and transmit up to the cloud. Well, most Wi-Fi access points, as we all know, have some form of authentication. We have to know what the access point is. We have to connect to it. We have to authenticate with it. And we have to be provisioned to work on that network. If we change any of those variables, the access point SSID, the ID of the access point, or its password, that device by itself no longer has an open channel to connect to the internet. So, we can orphan it, and it's just sitting there with, by itself, never able to alert you that, that there's a problem. So Sidewalk is interesting because what is it? And actually, this is something I think is in itself is likely going to revolutionize IoT as well. It basically is a way that allows us to use a secure network, but allow us to provision and have devices that go outside of our front door. We're not necessarily, and again, Amazon is all in on Matter, but they're also enabling, and Sidewalk is an Amazon specific protocol. It basically allows devices to connect to other devices that support Sidewalk anywhere within a neighborhood, within a community, or things of that sort, and provides that kind of that open channel that doesn't require all this provisioning and allows information to be shared up into the cloud. In this case, Amazon's cloud. So it's, if they're outside of the home or the Wi-Fi, a perfect example is a tag, a pet collar that is Sidewalk enabled that allows you to basically identify anywhere within a neighborhood, because it connected with somebody's Ring doorbell, that my pet is now 3 blocks away, and I can go search or find them. So it basically, Sidewalk is different from Matter in that way, and it's operated by Amazon at no charge to end customers. And it does consist, again, of an application layer and protocol stack, but it is based on a couple of other technologies out there. For example, when we said BLE is only used for provisioning in Matter, BLE actually becomes a communication protocol, and keeping in mind that we can communicate with BLE on a coin cell, so we could put something in a dog collar or things of that sort. And we can have, even if this BLE wanders over to somebody else's network, it can still communicate via this ecosystem. But beyond that, it has provisions for this beyond the Sidewalk in this sub-gigahertz protocol, this 900 megahertz protocol that allows us to have even longer range, and even longer range with this thing called chirp spread spectrum, also known as LoRa. LoRa has a home in Sidewalk, and LoRa, if you're not familiar with it, although it's a really low data rate in compared to many other, certainly against Wi-Fi and even BLE, in many cases, you're not looking for a large amount of data. You're just looking for, give me an ID, maybe a sensor reading. We're talking bytes of data, not megabytes of data. So even though it's a lower data rate protocol, it does allow us basically to have long range, upwards of possibly a kilometer or beyond. So through this, it allows us to build networks of whole communities. And the estimation right now by Amazon is that about 90% of the US is actually covered. And again, this is a free open network, unlike cellular. And while we do see cellular used quite a bit in IoT, and I'm not going to go into cellular today, but this solves that problem of, if I create a product, how do I know what environment I'm going in? This gives us kind of a uniform environment to connect to. It removes that need for proprietary gateway, very free setup, frustration free, very easy setup, automatic connection, and things like that. So it gives us the opportunity to build upon build a device that we today have a pretty high assurance, particularly if I have any of these other devices that are Amazon provided. For example, Ring doorbells. Ring is part of Amazon today. It's going to have basically Sidewalk built into it, and allows us to do connect to this infrastructure. There'll be bridges like the Ring gateway will have support for there. Even the spotlights on the side of the home will will have Sidewalk enabled. So we'll be able to identify where where these devices are. And even like professional bridges that will be set up community wide are not out of the question because of the range that, for example, church spread spectrum will give them. So things like a BLE tag, where is my Is my lawnmower and my, where did I leave it in my yard kind of thing. My water heater, all of these other products, my pool monitor, are all going to be enabled through like either, in this case, FSK or Bluetooth LE or long range. If I'm looking at, water management in a park, environmental management, agriculture, things of that sort that I may require, a kilometer or more, this CSS is going to be enabled by Sidewalk. And then ultimately, what's interesting is these become this upper layer, these application layers become uniform. You won't need to write them yourselves because this will be kind of an open standard. Again, you'll have to certify through Amazon when it comes to Sidewalk, but it does allow you to open up to an environment, and all of the software stacks and things like that are going to be, readily available for that. It will use sub-gigahertz, protocols, this FSK and the CSS protocols. And this is a way that we get very low power consumption, but very long range. So these are things that are there. We will be able to make the slides available, but here's one of the first products that we've seen on the market. Not one of the first, there's going to be many more coming, but this is, for example, a gas leak detector based around that's battery operated, 7-year continuous battery life that is Sidewalk enabled. And you'll notice that it has this the Bluetooth as well as this long range CSS radio built into it. And in fact, we're going to see things, for example, like this. This happens to be a supplier here in the Carolinas. Actually, they're based in Charlotte. Of a OEM module that will allow you to add Sidewalk into your existing products that are certified and ready to go. So we're going to see this whole infrastructure of, for example, 900 megahertz and 2.4 gigahertz Sidewalk enabled modules that are going to be available. All right, I've got about 3 minutes before I want to transition to question and answers. So finally, I want to go in and just talk about a different standard. And so, kind of to summarize, we've talked about Matter, and we talked about Sidewalk. Well, let's talk about YSUN, because a lot of people participating in Riot are interested in smart city, connected city type of environments. So while this may sound familiar, it is different than Matter and Sidewalk. So, for example, YSUN is an open standard. Again, there's that IPv6 and this 802.15.4 specification that is an open standard for what's called a field area network, or a FAN, and provide an ecosystem for the Internet of Things. Now, YSUN is not like how Sidewalk is only through Amazon. YSUN is going to be an open standard, but it does require these border router nodes, like as we saw with Sidewalk, our Amazon Echo could be our border router. Where in these cases, we can actually see entire ecosystems, that cover whole city blocks based upon, these gateways. It uses both sub-gigahertz and 2.4 gigahertz capability, like we saw with Sidewalk. But it has support for longer range and some things of that sort provided in that. It is not specific to the chirp spread spectrum, easy for me to say, that we saw, but basically it does have a provision for sub-gigahertz and things of that sort. So border routers, router nodes, leaf nodes are basically where we can have something that is a small battery operated type of device that can connect to a router node. And that router node could be a stoplight, it could be a street light, it could be, an access point tower that then ultimately is tied up to these border routers, which give us our, Ethernet backhaul. Okay. So this emerged out of, some of the more, I would say, industrial, like Landis and Gear and Itron, these were people that kind of organized around this standard. And they too, even in these industrial and smart city spaces, were plagued by these, all these variety of protocols that didn't necessarily work together. So basically, this is allowing us to bring some of these other infrastructure, things like, street lights, traffic signals, things of that, bring them together under an environment that they can work. Again, it's not tied into Amazon, but it does allow us, that we could clearly communicate up to an Amazon network if that was our endpoint destination. But it does allow us to work along this, and again, using IPv6 and things like that. It has mandatory security requirements. The stack does not look that vastly different than we saw with Sidewalk, but it is, available, and these are all kind of open standards based, and all this software is downloadable, and you can kind of hit the ground running. Okay, so street lighting, energy management, traffic controls, for example, smart parking kiosks, things of that sort, utility meters, storage, all of these things, waste management, where the ability to communicate, hey, I'm full, somebody needs to come by and empty the trash can. Environmental monitoring, flood hazards, things of that sort are going to be enabled basically by this. And you'll notice that many of these may actually be fixed kind of resources. They're bolted to something. They're not moving. Maybe the livestock are, but but you get the idea. Like, hopefully the trash can is where we left it. These environmental monitors may be where they are, but they enable, and they can enable these, this Wi-Fi network. So, we talk about a leaf node, things that are small, that can communicate to a router node that something is likely powered, going through a border router. And, it basically solves this long range IoT in a metro wide, and even things where we have building, and it does form kind of different on the fly mesh networks based upon these different environments, because they all communicate the same way. This is a kind of an RF spectrum map of a deployment in London, which I thought was kind of interesting. And you're seeing basically how this section of London has very wide coverage based off of all of these leaf nodes, or actually these border nodes and gateways that have been enabled in this environment. So I think you're going to see this more and more in this cases, and they're basically saying in this, there's 15,000 connected Wi-Fi devices, so parking meters. All of these different devices can be enabled and to work under a uniform environment. Again, the stack, you'll see a lot on the 802.15.4. All right, with that, ran a little bit longer than I'd hoped, but I wanted to, kind of just jump to the conclusion here and basically say, all of these new networks are coming out and they're being made available are, we're getting into, like I say, the mature phase of IoT. I get, as I was putting this together, I was saying, well, maybe an argument can be made that these new standards are going to be as confusing as the old standards. But I think more and more we're reaching that point where, as developers of IoT connected products, we have a lot more choices in terms of fewer choices, which is kind of an interesting way to think of it, is that we now no longer have to consider maybe 24 different protocols that don't work together. We can begin to take and get those protocols communicating up into the cloud in one uniform environment. So with that, I'll stop and see if there's any questions. So Jennifer.
Wow, that was fantastic. Thank you so much.
You.
If anyone in the audience has any questions, please place them in the chat, or raise your hand and I will call on you to unmute. And Paul, while folks are putting questions in the chat, what's the best way for folks to get in touch with you?
The best way, here, I'll put in the chat myself, is ppeterson@era.com.
Awesome. And are you able to share a copy of the PowerPoint with anyone who would like it?
Absolutely. Yeah, I will email that to you, and you can send it out to the. I've already made a PDF for it. So.
Yeah, if anyone would like a copy of the presentation, if they could email Paul directly, that would be great. This is being recorded, so it will be posted to our YouTube channel, and the link will be posted to the meetup groups, so you can get a copy of the recording there as well.
Fantastic.
Any questions from anyone? I'm not seeing any questions, but I'm happy to keep the line open for a minute. Otherwise, folks can have some additional time back in their day. Okay.
All right.
Awesome. Thank you so much for a wonderful presentation. As a reminder, Riot hosts our Lunch and Learns weekly on Wednesdays at 1 p.m. Eastern time. You can find a list of our Lunch and Learns on our meetup page where you registered for this event. This event was recorded, as I said, and will be posted to our YouTube channel and all of our meetup pages. Thank you all again for joining us today, and I hope that everyone has a great rest of your day. Bye.
Thanks, Jennifer.